Touch your hand. Go ahead. Touch it right now. You feel it, right? Solid. Real, physical contact. Here's the thing. You're not touching it. You never have. You never will. Your fingers are hovering above your hand. Always. There's a gap. Tiny. Unimaginably small. But it's there. And it will always be there. You've never touched anything in your entire life. Not your phone, not your bed, not another person, nothing. Every object you think you've touched, you were repelled by it, pushed away. Electromagnetically rejected before contact could happen. Solid matter is a lie, your brain tells you, and I'm going to show you why. But first, let me ask you something. If you're not touching your hand right now, what are you feeling? What's that sensation? Where's it coming from? Hold that question. We'll come back to it, because the answer is going to bother you more than you think. Look at the table in front of you, or the chair you're sitting on. Solid, right? Dense, impenetrable, made of atoms packed together. Except atoms aren't solid at all. An atom is almost entirely empty space. How much empty space? Let me give you a number that sounds fake but isn't. If an atom were the size of a football stadium, the nucleus would be a marble sitting at the center. The electrons, they're not even baseballs. They're more like probability clouds. Blurs of potential positions orbiting somewhere in the upper seats. Everything else? Empty. Nothing. Void. The entire football stadium is empty, except for one marble and some fuzzy clouds way out there. That's an atom. That's what you're made of. So if atoms are 99.99999999999% empty space, yes, that many nines, then why can't you put your hand through the table? Good question. Really good question. And the answer is stranger than you think. It's not because atoms are solid. They're not. It's not because they're packed tightly. They're mostly nothing. It's because of a force, the electromagnetic force. The same force that makes magnets stick to your fridge. When you push your hand toward the table, the electrons in your hand get close to the electrons in the table. And electrons hate each other. They repel. Violently. Not because they're touching. They never touch. They repel because they have the same electric charge. Negative. Like charges repel. Always. So the closer your hand gets to the table, the stronger the repulsion. The electrons in the table push back on the electrons in your hand. Harder and harder. At some point, the repulsive force is strong enough that your hand can't push any further. It stops. You feel resistance. Your brain interprets that resistance as solid. As touching. But you're not touching. You're being repelled. The table is pushing back on you electromagnetically from a distance. No contact. Just force. You know what that means? Every time you've sat in a chair, you were levitating above it, microscopically, but levitating. Every time you've held someone's hand, there was a gap, a tiny electromagnetic barrier keeping your atoms from ever actually meeting theirs. You've been alone your whole life, separated from everything by forces you can't see. Wait, that got dark. Let me bring it back. Here's something wild. When you press on a table and feel it push back, that's not the table, not really. It's the electromagnetic force, a field. Mediated by photons, virtual photons specifically. We talked about these before. They pop into existence, carry the force, then disappear constantly. Trillions of times per second. Your hand and the table are having a conversation in photons, an electromagnetic argument about who gets to occupy that space. The table wins, by the way, because it was there first and has more atoms backing it up. But here's the thing I want you to understand. The table isn't solid. It's a cloud of electromagnetic force that's really good at pretending to be solid, and so are you. Your body is mostly empty space held together by forces. If you removed all the empty space from your atoms, if you packed just the actual matter together with no gaps, you'd be smaller than a grain of sand, smaller than a speck of dust. All of you. Compressed down to pure matter. The rest is fields, forces. Electromagnetic repulsion, that's what gives you shape. That's what gives you volume. You're not solid. You're a pattern of forces that behaves like it's solid. Now let me tell you about something called the Pauli Exclusion Principle. And this is where it gets really weird. Electrons have a property called spin. Not actual spinning, but a quantum property we call spin because we don't have better words. And here's the rule. Two electrons can't occupy the same quantum state in the same place. Can't happen. It's forbidden by the laws of physics. If they have the same spin, they absolutely cannot be in the same place. They repel each other not just electromagnetically, but quantum mechanically. It's a deeper rule than electromagnetism. This is why matter doesn't collapse, why atoms have size, why you have volume. If it weren't for the Pauli Exclusion Principle, all the electrons in your body would fall into the lowest energy state and you'd collapse into a point, a singularity, gone. But they can't. The principle forbids it. So electrons stack up in different energy levels, different orbitals, building atoms, building molecules, building you. You exist because of a quantum rule that says, no, you can't all be in the same place. Isn't that strange? Your existence depends on electrons refusing to overlap. Now, here's something nobody tells you. There's a second reason you can't put your hand through the table, and it's even weirder. It's called degeneracy pressure, and it's what holds up dead stars. When atoms get pushed together really hard, the electrons run out of available energy states. They've filled all the low energy orbitals. They're forced into higher and higher energy states just to obey the Pauli Exclusion Principle. And that creates pressure, enormous pressure, pushing outward, resisting compression. This is what holds up white dwarf stars. Stars that have run out of fuel and collapsed under their own gravity. They're held up entirely by electron degeneracy pressure. Nothing else. Electrons refusing to be in the same quantum state. That's the force. That's what stops the collapse. And the same thing happens when you push on a table to a much, much smaller degree. But it's there. You're not just feeling electromagnetic repulsion. You're feeling quantum mechanical degeneracy pressure, a force that comes from the structure of quantum mechanics itself. Your hand is being held up by the same force that holds up dead stars. Think about that for a second. Every time you lean on a table, you're experiencing the same physics that prevents white dwarfs from collapsing into black holes. Quantum mechanics isn't just some abstract theory about tiny particles. It's the reason you can't fall through the floor right now. I've always said that if you really understand quantum mechanics, you should be freaked out by chairs. And I mean it! Because chairs shouldn't work. Not intuitively. There's no stuff holding you up. Just fields. Just forces. Just rules about which quantum states are allowed. And yet, chairs work perfectly. Every time. Nature doesn't care that it doesn't make sense to you. It works anyway. Now, back to that question from the beginning. If you're not touching your hand when you touch it, what are you feeling? Here's the answer, and this is going to sound insane. You're feeling the electromagnetic force compressing the atoms in your skin. When you press your fingers together, the repulsion between electrons squeezes the atoms. They deform slightly. That deformation triggers nerve receptors in your skin. The nerve receptors send signals to your brain. Your brain interprets those signals as touch. But nothing touched. Your fingers never made contact. The atoms in one finger never got close to the atoms in the other finger. What you felt was force, transmitted through fields, creating pressure, creating signals. Your entire sense of touch is a lie, a useful lie, a lie that helps you navigate the world, but a lie. You've never touched anything. You've only felt forces. Every handshake you've ever had, forces. Every hug, forces. Every kiss, forces. You are forever separated from the universe by electromagnetic barriers, alone in your cloud of repulsion. Okay, that's dark again. But it's true. And there's something beautiful about it too. Because even though you've never touched anyone, you've felt them. You've interacted with them through forces, through fields, through the exchange of photons and the repulsion of electrons. That's real, that's connection, just not the kind you thought it was. Here's something else. Temperature. What is temperature? It's not hotness. It's motion, vibration. At the atomic level, when something is hot, its atoms are vibrating fast. When it's cold, they're vibrating slowly. When you touch something hot, the fast vibrating atoms in the object interact electromagnetically with the slower atoms in your hand. They transfer energy. Speed up your atoms. Make them vibrate faster. That increase in vibration is what you feel as heat, but again, no touching happened. Just energy transfer through electromagnetic interaction. You've never actually touched anything hot or cold. You felt energy being transferred, momentum being exchanged, fields interacting, but not contact, never contact. Now, let me tell you about something really bizarre. Neutron stars If you thought white dwarfs were weird, neutron stars are worse, much worse. A neutron star is what happens when a massive star collapses and electron degeneracy pressure isn't enough to hold it up. The star keeps collapsing. The electrons get pushed into the protons. They combine. They become neutrons. The whole star becomes a ball of neutrons. And neutrons, it turns out, also obey the Pauli Exclusion Principle. Neutron degeneracy pressure kicks in, stops the collapse. Barely. A neutron star is a ball of neutrons packed so tightly that a teaspoon of it weighs 1 billion tons. 1 billion tons in a teaspoon. That's matter without empty space. That's what happens when the electromagnetic force is overwhelmed and atoms collapse into each other. And it's held up only by neutron degeneracy pressure. If you added more mass, even that would fail. The star would collapse into a black hole. So the only thing standing between you and gravitational collapse into a singularity is the Pauli Exclusion Principle. That's it. That's the barrier. You're one quantum rule away from ceasing to exist as matter. Comforting, right? Let me bring this back to something you can test right now. Push on the table in front of you hard. Feel that resistance? That's not the table. It's a force field. Generated by trillions of electrons refusing to let your electrons get any closer. You're pushing against a force field, like something out of science fiction, except it's real. It's everywhere. It's in everything. Every object you think is solid is actually a force field. A region of space where electromagnetic and quantum forces are so strong that other matter can't penetrate. That's what solid means. Not density, not hardness. Impenetrability due to force. And here's the kicker. You're made of the same thing. You're a force field too. A walking, talking region of electromagnetic repulsion that refuses to let anything else in. You and the table are both force fields. And when you push on the table, you're not touching it. You're forcing your field against its field, seeing which one wins. The table wins because it has more atoms, more electrons, more repulsion. But you were never going to touch it. Even if you could push your hand through somehow, even if you could overcome the forces, you still wouldn't touch anything because atoms are empty. You'd pass through the empty space between nuclei and electrons and come out the other side having touched nothing. Touching is impossible, physically impossible. So what does it mean to touch something? What does solid even mean? It means forces, strong enough to resist other forces. That's all. The universe is made of forces, not stuff. Forces, fields, interactions, matter is just a pattern of forces that's stable enough to persist, to hold a shape, to resist penetration. You're not made of stuff. You're made of patterns. Patterns of forces, patterns of fields, patterns that think they're solid. And those patterns are mostly empty space, held together by rules, quantum rules, electromagnetic rules, rules that say you can't be here and you can't do that. Without those rules, you'd collapse or disperse or cease to exist entirely. Your existence is contingent, held up by forces you can't see, governed by rules you didn't choose, and yet here you are, solid, real, feeling things, experiencing the world, even though you've never touched any of it. Now, every time you pick something up, you'll know you're not holding it, you're repelling it, keeping it at a distance, hovering just above it, levitating it with your force field. Every time you sit down, you'll know you're not sitting on anything, you're floating, microscopically, held up by forces that don't want you there. Every time someone touches you, you'll know. They didn't, they can't, they never will. You're alone in your bubble of force, forever, separated from the universe by the laws of physics, but you're still here, still interacting, still feeling, still experiencing connection, even if it's not the kind you thought. And somehow, that's enough. Matter isn't solid, nothing is. It's all forces, all fields, all interaction, and you're part of it. A pattern of forces that learn to think, to wonder, to question why you can't touch anything. Strange, isn't it? That the universe is held together by things refusing to get too close. Maybe there's a metaphor in there somewhere, maybe not. But now you know. You've never touched anything. You're levitating right now, held up by quantum rules and electromagnetic force. And you always will be. But wait. There's more to this story, and it gets darker. I told you atoms are mostly empty space. I told you electromagnetic forces keep things apart. I told you you're levitating right now, but I didn't tell you what's in that empty space. And the answer's going to break your brain a little. That empty space, it's not empty. Not really, not even close. It's seething, boiling, with particles that pop into existence and vanish constantly, trillions of times per second. Virtual particles, particle-antiparticle pairs, they appear from nothing, exist for an impossibly short time, then annihilate each other. Gone. The vacuum isn't empty. The vacuum is the most violent, chaotic, energetic thing in the universe. It just averages out to zero. So you don't notice, but it's there, between every atom in your body, between every electron and nucleus. The vacuum is screaming with activity. You're not made of atoms separated by nothing. You're made of atoms separated by quantum chaos. And here's the really disturbing part. Nobody knows why this doesn't tear everything apart. The energy density of the quantum vacuum should be enormous, unimaginably huge. It should curve space-time so violently that the universe collapses instantly. But it doesn't. The vacuum energy is almost exactly zero, or close enough that we can't measure the difference. Why? Nobody knows. It's called the cosmological constant problem, and it's one of the biggest unsolved mysteries in physics. You exist in a universe that shouldn't be stable. The vacuum should be destroying everything, but it's not, and we don't know why. You're held up by forces we understand, surrounded by chaos we don't, and somehow it all works. Let me tell you something else about density. You think some materials are denser than others, right? Lead is denser than wood, gold is denser than water. Makes sense. But here's the thing. The atoms in lead aren't more solid than the atoms in wood. They're the same. Mostly empty space, same structure. The difference is how tightly packed the atoms are, how close together, how much mass per unit volume. But the atoms themselves, still mostly nothing. The nucleus is still a tiny marble in a football stadium. The electrons are still fuzzy clouds. Gold atoms aren't more solid than carbon atoms. They just have more protons, more neutrons, more mass in that tiny nucleus. But the same amount of emptiness, the same electromagnetic forces keeping things apart. So when you hold a gold bar, you're not holding something more solid than wood. You're holding more atoms in the same space, more force fields overlapping, more electromagnetic repulsion concentrated in a smaller volume. Density is just how many force fields you've packed together. That's all. And here's something that'll mess with you. Pressure. When you squeeze something, you're forcing the atoms closer together, compressing the space between them. But the atoms themselves don't compress. They resist. Harder and harder as they get closer. At normal pressures, you can't compress things much. The electromagnetic repulsion is too strong. But at extreme pressures, like in the core of the Earth or inside Jupiter, things get weird. The forces start to break down. Electrons get stripped from atoms. Matter turns into plasma. Then something stranger. At high enough pressure, hydrogen stops being a gas, stops being a liquid, becomes a metal, metallic hydrogen, a form of hydrogen that conducts electricity. That's what's inside Jupiter. Liquid metallic hydrogen. The pressure is so high that the hydrogen atoms are crushed together. The electrons are ripped free. They flow like a metal, conduct like a metal, hydrogen. The lightest element, the simplest atom, turned into a metal by pressure. And here's the crazy part. We've barely managed to create metallic hydrogen in a lab. It requires pressures so enormous that we can only sustain them for seconds. But inside Jupiter, it's stable. Thousands of kilometers of metallic hydrogen just sitting there, conducting electricity, creating magnetic fields. Matter changes at extreme pressures. The rules change. The forces reorganize. New phases appear. And all of it is still mostly empty space, just compressed, squeezed, forced into configurations that don't exist on Earth. Now let me tell you about something really uncomfortable. Your body is changing. Right now, atoms are leaving your body, constantly, evaporating, diffusing, being replaced by new atoms. You breathe out carbon dioxide, water vapor. You shed skin cells. You sweat. You excrete. Every breath you lose atoms. Every moment new atoms come in, from food, from water, from air. The atoms that made up your body 7 years ago, most of them are gone, replaced. You're not the same matter you used to be. You're a pattern, a process, a flow of atoms that maintains a shape while the material constantly changes, like a whirlpool in a river. The water is always different, but the whirlpool remains. Same shape, same structure, different atoms. You're not a thing. You're a process that looks like a thing. And that process is mostly empty space, held together by forces surrounded by quantum chaos, constantly exchanging atoms with the environment. You're not solid. You're not permanent. You're not even consistently made of the same matter. You're a temporary pattern. That's all. And every other object you've ever seen? Same thing. Temporary patterns. Flows of energy and matter, pretending to be solid, pretending to be permanent. Nothing is solid. Nothing lasts. Everything is in flux. But here's the beautiful part. The pattern persists. You persist. Your identity persists. Even though the matter changes, that means you're not the matter. You're the pattern, the organization, the information. You are the shape the universe makes when atoms are arranged in a specific way. And that shape can persist even as the atoms change. You're more like software than hardware, running on matter, but not made of matter, made of organization. An organization doesn't need to be solid. It just needs to be stable enough, persistent enough, resistant to change. Now, here's something nobody talks about. Resonance. Every atom vibrates at specific frequencies. Electrons transition between energy levels at specific frequencies. Nuclei have resonance frequencies. When you push on a table, you're not just pushing against electromagnetic forces, you're exciting vibrations, resonance modes. The atoms are ringing like tiny bells. Most of the energy gets absorbed, dissipated as heat, but some of it reflects back. That's part of what you feel as resistance. You're not touching the table, you're making it vibrate, and the vibrations push back. Everything is vibrating always. At the atomic level, nothing is still. Thermal motion. Quantum fluctuations. 0-point energy. Absolute zero is impossible to reach because even at the lowest temperature, quantum mechanics demands residual motion. The atoms can't stop. The uncertainty principle forbids it. So even the coldest matter in the universe is vibrating, jiggling, refusing to be still. Nothing is solid. Nothing is still. Everything is motion, pretending to be static. Let me tell you one more thing about hardness. Diamond is the hardest natural material. Why? Not because its atoms are harder. Carbon atoms are the same everywhere. It's because of the way they're arranged. The crystal structure. The bonds between atoms are short and strong. The pattern is rigid. When you try to scratch diamond, you're trying to break those bonds, and the bonds are strong enough to resist most of the time. But at the atomic level, you're still not touching the diamond. You're pushing force fields against force fields. Testing which bonds are stronger. Hardness is just bond strength, how much force it takes to disrupt the pattern. And every material has a breaking point. Apply enough force and the pattern fails. The bonds break, the structure collapses. Nothing is indestructible, not even diamond. It's all just a question of how much force you apply. So when I say nothing is solid, I mean it. Not metaphorically, literally. Solid matter is an illusion created by electromagnetic forces strong enough to resist normal pressures. But apply enough pressure, enough energy, enough force, and the illusion breaks. Matter reveals itself for what it is. Empty space organized by forces, and those forces can fail. The organization can collapse. The pattern can be destroyed. You're not solid. You're stable. For now. Held together by forces that are currently strong enough. But not forever. Eventually the pattern will fail. The forces will weaken. The atoms will drift apart. The organization will dissolve. You'll stop being a pattern. Stop being a process. Stop being you. And the atoms will go somewhere else. Join other patterns. Other processes. Other temporary illusions of solidity. The matter doesn't disappear. Matter is conserved. But the pattern disappears. The organization, the information, you disappear. But the forces remain. The atoms remain. Ready to form new patterns, new processes, new illusions. That's what death is. The failure of organization, the collapse of the pattern, the end of the process that was you. But the universe doesn't care. The forces keep working. The atoms keep vibrating. New patterns form. Life continues, just not yours. Okay, that got really dark. But it's true, and there's something strangely comforting about it too. Because if you're just a pattern, just organization, just information, then what matters isn't the specific atoms. It's the pattern itself. And patterns can be copied, transferred, preserved, at least in principle. Your body is replacing atoms constantly, and you remain you, because the pattern persists. Maybe that's all identity is. Persistent patterns. Organization that maintains itself despite constant change. You're not your atoms. You're the way your atoms are arranged. And arrangement is information. Information can be copied. Information can be preserved. Information can, in theory, be transferred to different matter. That's a strange thought, but maybe a hopeful one. Anyway, you're not solid. Nothing is. It's all forces, all patterns, all organization pretending to be substance. Every time you touch something, remember, you're not touching it. You're interacting with its force field. Feeling its pattern resists yours. Every time you look at something solid, remember, it's mostly empty space, held together by rules, surrounded by chaos, temporarily stable. And every time you think about yourself, remember, you're not a thing. You're a process, a pattern, a flow of matter that maintains organization despite constant change. You're not solid. You're not permanent. You're not even made of the same atoms you were a few years ago, but you're still you. The pattern persists. The organization holds. The process continues. For now, and that's all we get. Patterns that persist, processes that continue. For a while. Until the forces fail. Until the organization collapses. Until the pattern dissolves back into chaos. But while it lasts, while a pattern holds, while you exist, you're something remarkable. A region of space where matter has organized itself into something that can think, can wonder, can question why it can't touch anything. And that's pretty incredible. Even if you're mostly empty space. Even if you've never touched anything. Even if you're just a temporary pattern pretending to be solid. You're here. You're thinking. You're experiencing. And that's more than most of the universe can say. So touch your hand again. Feel that sensation. Remember what it really is. Forces, fields, interactions, quantum rules preventing overlap, electromagnetic repulsion creating pressure, nerve signals creating experience. Not contact, never contact, but still something, still real, still meaningful. You've never touched anything, but you've felt everything, and maybe that's enough.